Okay then, so this first question for the year one paper 2, learning outcome 3 on differential calculus. So the first question, y equals 12x cubed plus 3.6x, differentiate this formula, is the first question, and we refer to the table you got at the front of the booklet to do it. So if y equals 12x cubed plus 3.6x, what do we do to differentiate it? We bring the power down, multiply it by the number in front, and then take 1 onto the power. 12 3 to 36, x cubed becomes x squared. And this, the x disappears and we're left with 3.6. This, of course, is now the differential, so dy by dx equals that. So that's the differential function, that's part A done. And in the exam there'll be a couple for you to have a go at, so you can just demonstrate that you can actually differentiate a function. Okay? Find the value of x when the differential is 0. Right, I can see now where there might be a little bit of a problem there. Yeah, in this question, the fact that that's positive means that you get a negative when you take it over the other side, which makes it complex. That's true. So, sorry about that. Let's make that a minus. So if this is a minus here, and assume that that's the question. And I won't make that mistake if it's best to do that in the exam. So, part B says, find the value of x when the differential is 0. So the dy by dx equals 0. Of course, if we plotted this thing, then this is some sort of quadratic, so we're going to expect an x squared, and as it's positive x squared, it's going to be some sort of curve like this. And so, when I'm letting this differential, dy by dx, equals 0, that's telling us something special about the function, isn't it? At what point does the dy by dx equal 0 on that curve? What does dy by dx tell us about the function? The gradient. Right. So I'm after, where on this curve is the gradient 0? At the bottom, no. The gradient is 0 at that point. So in other words, by allowing the differential to be 0 allows us to find maximum, or in this case, minimum values, okay? Which might be something that you could use it for in the exam. So if I'd said to you, instead of find the value of x when the differential is 0, find the value of x when the function is a minimum, then you need to understand that that's when the differential is 0. Because at a minimum point or a maximum point, the gradient is 0. So effectively, I'm asking you to find this minimum value. So we let 12x squared, 36x squared minus 30 minus 3.6 equals 0. So we've got this to solve. So by adding 3.6 to both sides, 36x squared equals 3.6. Dividing both sides by 36, we get x squared equals 3.6 over 36, which is in fact a tenth. So x squared equals 0.1. So to find x, we square root 0.1. Okay? So this equals 0.316. But of course, that could be plus or minus. So whenever we do that, we could always get two values. It's either positive or negative 0.316. So there's two possibilities for x. Well, it will make it. So part C says, hence find the values of y. So for part C, we go back to the original function, y equals 12x cubed plus 3.6x and substitute in our values for x. We put in either x equals positive 0.316 or minus 0.316 and work out what y is. So in other words, it's just saying at this point, right, I've found when x is when the differential is 0. Now let's try and find out what y is, putting our values in. So when you put the values in, you should get that y equals negative 0.38 or 1.138. So this question is about, and in the exam it could be about, can you differentiate a function? Can you maybe find the value of x when the differential is 0? Or can you put in a value of x and find out the value of y at this point? Things like that. Focusing mainly about the ability to use the table and differentiate a function. Correction, the y should turn out to be negative 0.76 and positive 0.76. So that's incorrect. So question number 2, here's another function to differentiate. Same sort of thing. Can you differentiate a function? This time it's a function that involves some trigonometric values. In fact, I'm just going to stop this video here and then we'll put number 2 on a separate video. So